Superconductors. They conduct with no resistance. They levitate magnets. They could solve so many problems, but they only work at freezing temperatures. However, scientists all over the world are working to find a room temperature superconductor. I was curious about this and wondered, what significance could the discovery of a room temperature superconductor have on the energy industry, and how could it solve problems? I answered this question by researching how they work, what they are used for, what physicists do to learn more, and their potential. Superconductors are amazing, but what exactly are they? How do they work? Superconductors are materials that, when at freezing temperatures, conduct electricity with no resistance. BCS theory is the theory of superconductors. According to the article BCS Theory on Wikipedia, in physics, the Bardeen-Cooper-Schrieffer BCS theory, named after John Bardeen, Leon Cooper, and John Robert Schrieffer, is the first microscopic theory of superconductivity since Heikki Kämmerling-Onnes's 1911 discovery. It was proposed in 1957, and the trio won the Nobel Prize for it 15 years later. According to BCS theory, the protons in a metal lattice are attracted to an electron, which creates a positive charge in the area, in turn attracting more electrons. These electrons are now paired up as a Cooper pair. These Cooper pairs are bosons, which allows them to exist at the same energy level at the same time. Near absolute zero, they all reach minimum energy and act as one particle. They move without colliding, which is the cause of resistance, and superconductivity is achieved. Superconductors have another amazing property: quantum locking. Quantum locking is when a superconductor and a magnet get attached to each other without touching. One levitates above the other. This is all great, but what can these things even do? Superconductors do all sorts of things. Superconductors can be used to build SQUIDSs, squids, which are extremely sensitive to magnets. They are also currently used to build MRI machines. Finally, superconductors are used to power as well as levitate maglev trains. According to the article, The Future of Superconductors, A Pathway to a More Sustainable World, the superconductors are used to create magnetic fields that levitate and propel the train. There are also a lot of potential applications. Superconductors have potential to build better, more efficient power grids that replace normal conductors with superconductors, which reduces energy loss. We could also use superconducting technology to create quieter, smaller, much more efficient motors and generators. A superconductor can not only reduce energy loss, but make more electricity in the first place. According to the article, making superconductivity useful, one application of high-temperature superconducting cables is to build very lightweight electrical generators. These applications and many more make superconductivity very useful. A room temperature superconductor would be a big deal. Because this discovery would be so important, physicists and chemists are working extremely hard on it. The problem is, we don't know exactly what an ideal superconductor could look like, so scientists have to take educated guesses. Eventually, we make discoveries. In conclusion, a room temperature superconductor would have a huge impact. If we had room temperature superconductors, we would save tons of energy. We wouldn't waste any electricity in generation or production, which would solve so many problems. Lower energy consumption would mean less environmental impact, as well as lower energy costs. Although it wouldn't be an easy, instant, 100% effective solution, it would still help a lot. Such a superconductor could also make MRIs, maglev trains, and so many other applications much more accessible. While we are getting closer, there are still many hurdles to overcome.